Okay, so let's look at the next one. Number 41. Similar triangles. All right? So we have used the similar triangles below to answer 41 and 42. So let's look at that. If you did not get some part of these things, ask questions. We will have to explain to you more or go back to everything we did there. It is self-explanatory. All right. So let's look at the next question. Okay, so use the similar triangles below to answer question 41 and 46. So if we look at the two triangles, the first triangle is triangle TSU, and the other one is triangle VXW. Now, in solving similar triangles, okay, what you should look at is to get the positioning of each of the parameters that is in the both angles, okay? For example, you see an angle here. Just follow your screen, follow the position of my mouse, okay? You see, of my cursor rather, you see this angle S, where you have two double line, right? Double line here, or double arc, right? All right. That it means that angle S is equivalent or is similar to angle W, CW, in this second angle, okay? In this second triangle. So this one is similar to this, right? So if you have angle U in this other one here, angle U here is also similar to angle V. Can you see that now? So in the second one. So what it means is that if you have a side, listen to me carefully. If you have a side of this angle, this first one, angle TSU, if you have a side labeled around this double arc and single arc, let's say this 6. Remember, the position of this 6 is around or is adjacent to angle S and angle U, such that this side makes contact with these two angles. So this 6 is in the same positioning, okay, with HCM, because the line touches the double arc and the single arc. You get the point? Just like the line for 6 cm here touches double arc and single arc. That is number one. If you look at 3 cm, it touches only, it is only directed to the single arc. To the single arc. That is this TU, 3 cm, single arc. You look for the next triangle. Which one is directed to just single arc? It is XV, but unfortunately XV is not giving anything. You don't understand me now? So XV is similar to 3 TU, that is 3 cm. Then you go to the next one. See this other one there, ST, that is ST, this ST here, okay? This line or this side is only directed to the angle with double arc. You see what I'm explaining now? So you check it, you compare it with this other angle. We only have 12 cm, okay, to be the angle that is corresponding to this other angle, okay? So once you have that idea, that point, the next thing you do is to find the proportion of the two, the ratio of those two angles, right? So the question is now, in 41, calculate ST. ST is this, ST is this, okay? So to calculate ST, what is similar to ST in this other triangle is what? That is angle XW, that is 12 cm. Do you get the point now? So we are going to make a relationship between ST and XW. So we say ST, look at the board now, we say ST ratio XW. Can you see that now? So ST is SW or WX, whichever one you want to use. So now, because we are going to look for another of it in the other triangle, we now say equal to, we cannot choose two angles here that have the same, that are given both here and here. If you look at SU, 6 cm is given, WV, 8 cm is given, right? So we say equals to SU ratio VW. Is that okay now? So what we have in ST, which is what we're asked to find. So XT over XW, that is 12 cm, is equal to SU 6 cm all over VW 8 cm. All right, you get that now? So we have ST, which is for the first triangle, which is what we're looking for, okay, is in proportion, okay, to XW because of the side where they are found. Okay, I explained that just before we started, okay? While SU in the first angle, which is 6 cm, is in the side where you have the double arc and single arc. You have it in the same place where you have VW, okay, which is 8 cm. All right, so let's go. All right, so cross multiply. So this will be 8ST, or yes, now 8ST is equal to 12 times 6, right? So divide both sides by 8, right? That is what it means. So so ST will be equal to 2 here is 3, 2 here is 4, 4 here is 1, 4 here is 3, 3 times 3 is 9. So ST is equal to 9 cm. So ST is equal to 9 cm. So option C is the correct option there, 9 cm. Is that okay? All right, so we'll go to 42. 42 says we should calculate XV, that is in the second triangle, XV, all right? So what you do also, look for the similar side for XV. So it means that XV is in ratio to XV is on the side where just the single, what is it called? Single arc, okay? So we have single arc here too. So XV is TU. Ratio TU is equal to, so let's get another place. This time, we can still do this one, okay? We can still do SU, right? Okay, we cannot do, what is it called now? We have, remember, we have what ST is now. So if we use 12 cm, we know what ST is, right? So if we use 12 cm here to say XW, which is 12 cm, so XW, remember, because I use XV first, also use it here. Don't go and use it in the second place. So XW is XW ratio. Let's look at it. Let's look at what it has there. It's in ratio ST, all right, which we know the ST. So XV over TU. What's our TU? TU is 3 is equal to XW. XW is 12 over ST. Our ST, which we have just gotten now, ST is 9. All right. So this will be XV9, right? Or 9XV. 9XV is equal to what is it? 3 times 12. That's, I simply cross multiplied. All right. So we have 9xv divided by 9 divided by 9. So this xv, which is what they are asking us to find, will now be equal to 3 here, 1. 3 into 9 is 3, right? 3 here is 1, 3 here is 4. So xv is equal to 4 cm. All right, so that is what it means. xv, 4 cm, we have it here. All right? Okay, so let's go to the next one. We are getting to the tougher questions. All right, so the question here is, you can see the screen, right? There is not so much explanation in this. You should know what it is. The construction below represents which angle? Which angle? Okay, I think I should just recall your attention to something you already know, but I think that is angle 60. And I will tell you why. You know, if you want to construct, that is 40 what? 3. If you're constructing angle 60, make a straight line, draw a semicircular arc. Okay? Draw a semicircular arc. All right? With that same semicircular arc, with that same radius, just come to any side of this thing, draw an arc. Come to this side to draw an arc. Each of these things that you have made there from this center is 60 degrees. So this is also 60 degrees. So this is 60, this is 60, and this is 60. If you add the three together like this, it will give you 180 degrees, which is the sum of angles inside a semicircle. Do you understand? So that thing you have there is 60 degrees. All right? Okay, so this is 60 degrees. So let's go to 44. Calculate the area of the shaded portion of the shaded region in the figure below. All right, let's calculate that. 44. So they said we should calculate the area of the shaded region in D. So the shaded region is the region outside of the circle. So to calculate the area of the shaded region is to find the area of the rectangle, then remove the area of the circle from the rectangle. You have found the area of the shaded region. Is that okay now? All right. So because the point is that it is not all the area of the rectangle that is shaded. So some part of it, there is a circular part of that. Is there a rectangle? No. Of a square, rather. So sorry about that. So it is not the entire area of this square that is shaded. Okay? Some part of it are enclosed inside in a circular form and they are not shaded. So for you to find the area that is shaded is find the total area of the rectangle, then subtract, remove that unshaded part from it, you get the shaded part. Do you understand me? So area, look at the formula here. Area of shaded is equal to area of entire square subtract area of circle from it. Simple, you get the area of shaded part. Is that okay now? All right, so let's do that together. So look at this. This circle has a diameter of 7 cm. Don't confuse, because they had to put that 7 cm for you at the middle of it. So that means that 7 cm is not radius, it's diameter. So you must convert the diameter to radius for you to use pi r squared for area of a circle. Do you understand me now? All right, so let's look at that now. So what that will mean is that area of just shaded region. So ASR, permit me to use that, is area of shaded region, all right, is equal to area of the entire square, which is 10 times 10 minus area of circle. What is the area of circle? Pi r squared. So it's 22 over 7, right, times r squared. That is 3.5 squared. How did I get 3.5 squared? 7 is the diameter, as you can see on the screen, while the radius is diameter over 2. 7 over 2 is 3.5. All right? Okay, so let's do that now. So this will now give us 10 times 10 is 100 minus 22 over 7. So we have been able to know that 3.5, right? 3.5 gives us, the square of 3.5 is 12.25. 3.5 times 3.5 gives us 12.25. So 12.25 times 22 give us 269.5, which we saw that time, right? So this is 269.5 over 7. Is that correct? Okay. 269.5 over 7. All right, so we just do divided by 7. So 38.5. So this is 100 minus 38.5. That is what it is, okay? So 100 minus 38.5, 61.5. So this will give us 61.5. Did they ask us to convert to anything? Okay, nothing. So 61.5 is the correct option. Option B, all right? All right, let's move to the next. Okay, two similar cylindrical tins are 6 cm and 9 cm high. All right, so if the smaller tin has diameter of 8 cm, find the diameter of the bigger tin. It's still what we just did now, is similar shapes, okay? So let's look at these. So two similar cylindrical tins are 6 cm and 9 cm high, okay? If the smaller tin has diameter of 8 cm, so wait, what it means is that for 6 cm, it is equivalent to 8 cm. You see that? Right? 6 cm, they say if the smaller tin has diameter of 8 cm, find the diameter of the bigger tin. So it will now be equals to the bigger tin high is 9. So is to x. Let's say it is x. Do you get the point now? So two cylindrical tins are 6 cm and 9 cm. So one is 6 cm, one is 9 cm. Now they say if the smaller tin has diameter of 8 cm, so it means that 8 cm is to 6 cm. 6 is to 8 cm. 9 is to how many cm in diameter? We don't know. So they say we should find the diameter of the bigger one, which is what we did here. So let the diameter be x, right? Okay, so this will be 6 over 8 is equal to 9 over x, right? So this will be cross multiply. So this is 6x is equal to 8 times 9, right? So this will be 6, this will be 6. 6 here, so x here will now be equal to 2 here, 3, 2 here, 4, 3 here, 1, 3 here, 3, 4 times 3 is 12. So this is 12 cm. So the diameter of the second or of the bigger tin is 12 cm. All right? Okay, let's go to the next one. Now let's look at this now. They say we should use this figure below to answer questions number 46, 47, and 48. So you must pay a very careful attention. This is trigonometric question. So you must give me a rapt attention so that you understand the concept of how the questions will be solved, okay? So let me draw the diagram for you. Let me draw it here so that I can explain easily from here. All right, this 90 degrees, that bench there. Then here is 60 degrees. Then here 30 degrees, right? Then here is A, B, C, and D, right? So they are asking the first question, find line AB. So find AB. So they say we should find AB. Now look at this question very well. Okay, this is 10 centimeter. Okay, it's 10 meter. All right. So they're asking us to find AB. Now, if you look at this angle, we have like 2 or even 3 triangles here. Triangles. We have the bigger triangle which houses all of them, one. Then we have, we have angle ABD first. Then we have angle ABC. Then we have angle ACD. Do you understand the point now? All right, so now they're asking us to find the length of AB, right? The length of AB. So the length of AB is simply to find this side. What is this side? So the angle we are considering is angle, this is my way of writing angle ABC. Now, we have to find this. I know this is a right angle triangle. If we had what this thing is, you would have used Pythagoras theorem and just square this side, you will get this. But in a situation where a triangle, you have just one of the sides given and an angle given, another side of that triangle can be sorted out, can be found. How? If you can remember your trigonometric ratios, right? When you learned trigonometry and you were told something about SOHCAHTOA, okay? I believe you can remember now. SOHCAHTOA, where this means sine is equal to opposite over hypotenuse, right? This means cos, that's cosine, is adjacent over hypotenuse. Then this tan, this thing means tan, it means opposite over adjacent, right? And you should understand what an opposite means. Opposite means where the angle is facing, the direction or the side of the triangle where the given angle is facing. For instance, in angle ABC, this is our opposite because this angle is facing this side, right? Why this, of course, our hypotenuse is always constant, is the longest side. Of course, this will not be our adjacent. You get the point now? So you ask yourself, which trigonometric ratio or which trigonometric concept will you put up to make sure that you can have this angle given here, then include here and include adjacent? So we have said that this is our opposite, right? This is our adjacent, ADJ, right? This is our hypotenuse. So to make use of this, it means it is facing opposite. So let's look at where we have opposite. And the next thing we are considering is adjacent. Remember, there is nothing here. So we are considering opposite and adjacent. So which one? It is what for tan. Tan says, tan is used when comparing opposite and what? Adjacent. So we say tan theta. So we say tan theta is equal to opposite all over what? Adjacent, right? Opposite all over adjacent. Now, our tan theta is 60, right? Our theta is 60. Theta means the angle you are given in the triangle, right? The angle that you are given in that triangle. So our angle is angle what? 60. Look at it here. This is the angle the triangle we are looking at. So this tan 60 degrees is equal to, what is our opposite? Our opposite is AB. You see that now? Which is where they ask us to find. So AB, right? Divided by our adjacent. What is our adjacent? Our adjacent is 10 meter. So all over 10, right? So that is it. So if we cross multiply, this will be AB is equal to 10 times tan 60 degrees. So AB will now be equal to, you have your calculator, okay, you just check tan 60 degree or even your 4-figure table, but I will use the calculator and I will just touch tan 60. All right, close the bracket, and tan 60 is root 3. So this means 10 times root 3. So it means that, therefore, AB is equal to 10 root 3 meter. Right? Remember, this is not 30 because this is a short form, okay? 10 is not in short form, so it cannot affect what is in short form, all right? So this is 10 root 3. 10 times root 3 is 10 root 3. 20 times root 4, 20 root 4, just like that. That is how it's done, okay? So our AB is 10 root 3, which is option B, which is the correct option there. 10 root 3, right? Okay, so let's go to the next one. So the next one says, calculate AD. So 47. 47 says, calculate AD. What is our AD? AD is this line here, this hypotenuse of the larger triangle. So what is AD? AD. What is our AD? Right? What is our AD? What is our AD? Now look at it. Remember, so it means that first of all, we have known that opposite now is 10 root 3. So AD, to use AD, we can use this entire triangle. So let's consider triangle ABC. You understand the point now? Triangle ABC. Because we are looking for AD. Do you understand me now? We have, remember, we now have a value for opposite for this one. Okay? So if we want to look at that now, we are looking at triangle A, B, and D. Do you get the point now? So if we come back here, AD being the hypotenuse, this is the angle we are going to use. Because this angle 60 is only for ABC. But for angle ABD, 30 is an angle inside angle ABD. Do you understand the point now? So this angle is 30. The opposite side of this entire angle is this side. Remember, opposite side is the side that is facing the angle, right? So it means that whatever sign or whatever ratio we use, whether sine, cosine, or tan, it will give us the one that will be opposite over hypotenuse. Opposite over hypotenuse, if we come here, it is sine, right? So we say sine theta is equal to opposite over hypo, right? So we know our tan theta and sine theta to be 30. So our sine theta is 30. So sine 30 degrees is equal to, what is our opposite now? What is our opposite? We have gotten our opposite to be what? 10 root 3. That is opposite of this triangle. In this larger triangle, this is the opposite. This is now the adjacent. The whole of this place is the adjacent. Why this is the hypotenuse? The hypotenuse, I told you, is always the longest side, is constant. So this will now be 10 root 3 divided by, what did they ask us? AD. So divided by AD. AD. Is that correct? That is correct. So what that means is that if we cross multiply this over 1, right? So this will be sine 30 degrees AD, right, is equal to 10 root 3, right? 10 root 3. You see that? So if we divide both sides by sine 30 degrees so that AD can be on its own. So it means this is over sine 30 degrees over sine 30 degrees. So this we move. So we have AD to be equal to 10 root 3 over, what is sine 30 degrees? So we look at our calculator and punch sine 30 degrees. We punch that, it gives us 1 over 2. So this is 1 over 2. You see that? All right, but now this is what we do. Remember, this is equal to, so let's have our AD to be equal to 10 root 3. And remember, this over 1 times, remember, this will go up, this will come down. 2 over 1, right? So this will now be equal to, remember, I said multiplying a real integer or a real number with a number in short form is not possible. So these two can only multiply 10 because 10 is a like term, just like it, right? So this 2 multiplies 10, right, to give us 20. This root 3 will still be there. So this is the answer. So AD, this AD is 20 root 3. 20 root 3. This is 10 what? Root what? 3. So we have 20 root 3, which is option B, to be the correct option there. 20 root 3, right? Okay, so let's go to the last one in this particular diagram. They say we should find CD. Now look at this, CD. CD. Do you get the point now? They say we should find CD. Now in this CD, there is no way we can find it with just here, and with triangle ACD, because this place is not given 1. And even if it's given, this is not a right angle triangle to even start with. Do you get the point now? So now we can find that with the entire angle. Let me, okay, so 40 what? 48, right? So 48. 48, they say we should calculate CD. CD. Okay? And that CD, we'll get it from triangle ABD. ABD. Right? Good. So, I think what we should do, let's ignore that we have 10 cm. Let's get what this whole place will be. We have gotten here. We have gotten here. Let's know what this entire place will be. You get the point? We have gotten here, we have gotten here, so let's know what this entire place will be. We will still have to use our trigonometric ratios, right? I know somebody may have been thinking, okay, let's use Pythagoras theorem. We can use Pythagoras theorem. Since we have here, we can get here. But please, hope you know that these are not real numbers, right? So you will have some issues. You will have a long process solving this, okay? So let's still use trigono, all right? So let's say if we use this is the angle we refer to, all right? Now we're having opposite over what? Adjacent. These are opposite over adjacent. So that is tan, right? So let's do that. So it means tan theta, just like is opposite, don't forget, over adjacent, right? So our tan 30 degrees, which is this, all right, is equal to, opposite is 10 root 3 divided by adjacent is BD, line BD, right? All right, so we can cross multiply, right? This here, so tan 30 degree BD is equal to 10 root 3. Is that okay now? So if we divide both sides by tan 30 so that we can have just BD here. So this is over tan 30 degrees over tan 30 degrees. So tan 30, tan 30. So we have BD, all right, to be equal to 10 root 3 over, what is tan 30? That is the question you ask. So you go to your calculator and you punch tan 30. It will give you root 3 over 3. So it's equal to root 3 over 3. Okay, two fractions dividing themselves. So this is BD is equal to 10 root 3 over 1 times 3 root 3. This division change this one up and this one down, right? So this will now be equal to, this is BD, will now be equal to 3 times 10. Remember I said you can only multiply what is not, what has the same like 10. This is root 3, so 3 cannot go to this 3. Cannot go and multiply this 3. 3 can only multiply this 10. So 3 times 10 is 30, right? That is correct. So we have 30 root 3. 3 times 1 is this. 1 times anything is that thing. 1 times 20 is 20. 1 times x is x. 1 times v is v. 1 times anything is that thing. So 1 times root 3 is still root 3. So root 3, right? So root 3 can divide root 3. So BD is equal to 30 meter. BD. Now, I told you that these guys can be very tricky if you look at your option. Because you have solved to this point, you may just be thinking, wow, you have exhausted a lot of time and you have solved, you have gotten BD, and you forget that it is not BD that you're asked for. You are asked for CD. So BD, you see, option C, they gave you 30 and you have 30 here. You can just be carried away and you go and mark 30, you will fail it. All this, your effort will be in vain. Do you understand? So all you need to do is, they say CD. So how do you get CD? To get CD, go back to this diagram. If BD is 30, meaning from here to here is 30, to get only CD is to subtract BC from BD, you will get CD. You get the point? So what it means is that you say, therefore, CD is equal to BD, which is the entire, this is minus BC. Our CD now will be equal to 30 meter minus BC is 10 meter. 10 meter. So this will be 20 meter. So our CD, line CD, is equal to 20 meter, right? So our correct option there is option A. All right, so that was a lot of time we spent there. It's because of how technical that question was. Which of the following angles cannot be constructed using a ruler and a pair of compasses only? Now, listen to this question. Listen. It says, which of the following cannot be constructed by a ruler and a pair of compass? Almost all angles can be constructed. 360 can be constructed. Angle 2 can be constructed. Angle 1 can be constructed. Angle 17 can be constructed. But those angles can only be constructed using a protractor. So you can put a protractor and trace. You understand me? But there are some special angles that can only be constructed using a ruler and a pair of compass. All right? Those special angles, okay? For example, 360 degrees, that is a full circle. Okay? 180 degrees can be constructed. Right? 90 degrees can be constructed. Do you get the point now? 60 degrees can be constructed. 45 degrees, 22.5 degrees. Even in 22.5, you can even get 11.25 degrees. We can keep dividing. Do you understand? Those things are called special angles. We can construct 30 degrees. Okay? We can construct 45 plus 30. I think 45 degree plus 30, that is about 45, 30, that is about 75 degree. We can even construct that. Do you understand that now? So we can construct some of those, but there are some angles that there is nothing you can do to construct them. So 70, for instance, cannot be constructed. There is no magic you will do. We can even construct 75. Do you understand me? But for 70, it can't be constructed. So 70 cannot be constructed using a ruler and a pair of compass. 30 can be constructed, 45 can be constructed, 90 can be constructed, 120 can be constructed. All right? All right, so let's go to the next one. Find the area of the figure below. Okay, so let's look at this. So we should find the area of the figure below. Remember, area of a rectangle is for this, where we have two sides given and an angle. The area of a rectangle, you always know the area of a rectangle to be half base times height, but in triangles where you are given an angle and there is no base given to you, all you do is another formula for calculating area of a triangle. You must pay attention to this, please. So let's say, okay, so area, that is 50. Area is equal to half AB sine theta, where A and B is the two sides of the triangle that are given to us, okay? So this is equal to 1 over 2 times, the first side is 8 cm times B, the other side, root 4 root 3 times sine theta. What is our theta? 30. That is sine 30 degrees. Do you get the point? So this will be, okay, if we can even, this here is 1, here is 4. Is that okay now? So what that means is 1 times 4 is 4, 4 times 4 is 16, right? So this is 16 root 3 times sine 30 degrees, right? So what is our sine 30 degrees? Go to your calculator and do sine 30 degrees, right? So you get 1 over 2. So sine 30 is 1 over 2. So we have 16 root 3 times 1 over 2, right? So this 2 into itself is 1. 2 into 16 is 8. So our answer becomes 8 root 3 meters. Is it given in meter? Yes, meter. All right, so 8 root 3 meter. Let's see if we have it. Yes, 8 root 3 meter squared. They are asking of area. So option B is the correct option there. 8 root 3 meter squared. 8 root 3 meter squared. So let's go to 51. 51. Find the radius of a circle whose circumference is 22 cm. All right, so that is pretty simple, right? 51. So we have circumference of a circle is equals to 2 pi r, right? Very good. So circumference is given to us as what? 22 cm. So put 22 cm in place of c is equal to 2 times, they say we should take pi to be 22 over 7. So 22 all over 7 times our radius. Say find the radius of a circle. So that is what they're asking us to find, radius, right? Good. So once we have done that, this is now 22 is equal to 2 times 22 is 44 times r is 44r all over 7, right? So if you cross multiply, we'll have 44r is equals to 22 times 7, right? So if we do that, it means that to remove 44 from r, so we'll go to 44, divide both sides, right? So this removes this, r is not alone, okay? But then we can do 22 into itself is 1, 22 into 44 is 2, right? So we have r is equal to, what is left here? This 22 into itself is 1, 22 into 44 is 2. So 1 times 7 is 7 all over 2. So our r is equal to 3.5, is it meter or cm? So that is the value of our r, okay? 3.5 cm, and that is option D. All right? Okay, let's go to 52. 52 says, calculate the area of a triangle whose base is 5 cm and height. Okay, so this is the one you're used to, not this type. All right, so this one is just a straightforward thing. 52 area of a triangle is equal to half base times height, right? So half base times height. So the base there is 5 cm, height is 2 cm. So it's equals to 1/2 times base is 5 cm, height is 2 cm. So 2 cancel 2, it means the area is 5 cm square, right? 5 cm square. So it's option C. All right. So let's look at this. The angle of elevation of the top X of a vertical pole. So let's draw that. 53. So this is the top. So they say the top is X. So let's not forget. Okay? When drawing angle of elevation, because it is important you draw it so that you will understand what the figure looks like, so that you know how to add it. Okay? Okay. Now, they said the angle of elevation of a vertical pole from a point P on the ground level. So let's have the ground level here. This is our ground level. And they say angle of elevation. Angle of elevation is angle at a height. Okay? The angle that you make with your eyes to the level where you started seeing, that angle you make from the position of your sight to where you're looking at. So if this is the level of my eye, okay, and I want to look up, let's say I want to look at this point, so where my eye is going to, okay, if this is my eye, you can see that there's an angle being made here. That is called the angle of elevation, angle of raising your eye up, okay? While angle of depression is if you're up and you're looking at something down, that angle that forms should going down. So angle of elevation faces up, angle of depression faces down. Is that okay now? So let's see this now. So they said this man is standing at point P, and the man is looking at a height, a vertical pole. Probably, let's say these PHEED people came to your whatever and they want to cut the line, and there is one man on the pole. So you're looking at the man climbing the pole or something. That is an angle of elevation. Do you get the point? So this is you at the level of your eye, and you're looking at this man standing here at X. Now this is the vertical pole. Can you see that now? This is the vertical pole. This is the pole that this man is climbing to, and he's here. You are here. You are looking at this man here. You get the point now. So now look at the question again. Go back to the question. The angle of elevation of the top of a vertical pole from point P on the level ground is 45 degrees. So this place is 45 degrees from the ground level. This is the ground level, or where this is ground level. Do you get the point now? Then if the distance from P to the foot, that is, if the distance from P, remember this is P, okay, and this is the foot of this pole, of this vertical pole. This is the foot, right? This is the pole, this is the pole, vertical pole, right? So they say if the distance from P to the foot, P to foot, they say if that distance is 7 meters, here is 7 meters, right? So they say find the height of the pole. What is this height? You see this height? What is it? Height is what? This height that this man is climbing to. So of course we also have to use our trigonometric ratio because we have an angle here. This angle is facing the height, okay? So the height is our opposite and adjacent. So tan theta is equals to opposite all over what? Adjacent. So tan 45 degrees is equal to opposite is our height, right? And our adjacent is 7 meters, right? So it means that our height, if we cross multiply, height times 1 is height, is equal to tan 45 degrees times 7 meters. 7 meters, right? So height will be equals to tan 45 degrees. I think that should be 1 or something. Let's see. Tan 45 degrees is equal to 1. Yeah. So tan 45 degrees is equal to 1 times 7 meters. So it means that our height is 7 what? meter. So our height, the height is also the same thing with the foot, okay? So the height is 7 meter. I hope you're following that now. So let's look at 50. They say we should use it to answer 54 and 55. Okay, this one, we don't need to solve anything. From what you can see on the board here, or on the screen rather, you will understand what it is. So use the diagram below to answer question 54 and 55. So let's look at it. They said we should find the size of, look at this diagram very well. We have a straight line, AB, right? And a meeting point or a central point or a center or the point of origin O here. I hope you are seeing the cursor of my mouse here, this arrow moving. Now we have from the origin, we have line R, RO. We have line OP. We have line OQ. We have line OB. We have line OA. So now they're asking us, find the size of angle ROQ. Now, in mathematics, they say we should find the size of angle ROQ. Look at that on the screen, on the board right now. All right, just look at the board. So, angle ROQ, from what we have on the screen, okay, I think it is better I draw this on the board so that you have a better understanding when I explain it. Okay, let's have this. This is what we have there. These points, origin, this is our B, this is our A, then we have P, we have Q, we have R. Is that okay? Okay, so we have something like this. This is what we have there, right? So the question is, we should find the size of angle ROQ. That is ROQ. ROQ, right? Now, when you are asked to find an angle from a figure, all right, you know, in this thing now, we have R, we have O, and we have Q. We have these three alphabets. Now, they will either put this in for you like this, or some persons will say R, O, Q, and put this angle sign on top of O. But whether they put the angle sign on top of O or not, once you see angle and you see the sign of angle before the alphabet, the angle that is considered, or the part of that is considered, is the middle, that middle zero, meaning here. If this is angle ROQ, so they are talking about this thing from here down to this place. Do you understand? That's what they're asking. They're asking, what is the size of from this angle down to this angle? That is angle ROQ. That is this angle, ROQ. So what is the size? Now, before you can know this, you must understand, this is a straight line, right? And this is a line that cut this straight line into two. It means this side is 90, this side is 90. Are you listening to me? This side, the whole of this side, both here and here, 90. Whole of this side, 90. So in that 90, they now bisected. If you have a very good understanding of construction, you will know that in this angle 90 degrees that have been formed, this right angle triangle, it was also bisected. And we have here 45, here 45, here. They also did the bisection. Here is also 45, here is also 45. Can you see? Can you see? So this is 4 45-degree angles. So 45, 45, 90, 45, and 45. So this is 90, this is 90. Summing everything together, 180 degree, because some of angles on a straight line, some of angles on a straight line is one. So they're asking you ROQ. So it is just simply ROQ. So you say angle ROQ is equal to 45 degree plus 45 degree, which is equal to 90 degrees, right? So 90 degree is option B, all right? So that is that. Very simple. Very simple. Then the next one they're asking us is calculate, that is 40 what? 55. 55 say calculate sum of AOP, that is angle AOP, and angle QOB. So let's look at that. So this is equal to, so they say the sum of two sets of angles now. The first one is AOP rather. So this is AOP. Now, AOP is talking about this angle. Can you see? I'm tracing it now. This angle. And I know somebody can intelligently tell me what the size of that angle is. This is 90 degrees. This is a right angle triangle. So we are dealing with the whole of this place. So AOP is equal to 90 degrees plus, now they say the sum of AOP and what? QOB. So this is QOB. QOB. So they are talking about just this place. QOB is 45 degrees. So this is 45 degrees, excuse me. All right. So 45 plus 90. 0 plus 5 is 5. 4 plus 9 is 13. So 135 degrees. All right. That is the size of, that is the addition of those two. So 135, we'll have it here. 135. So we'll go to the next one. We're almost done. Getting to the, all right. So let's see. Now look at this. They say find the area of the figure below. The area of the figure below. All right. Now look at this. Area of triangle 56. Area of triangle is equals to half times base times height. But these people are quite tricky. You know, they did not ask you to find the area of this, just this side. They say the area of the entire triangle. Now, what we have to do is we have to know the base of this triangle. We have 6 in this side, but this other side, just look at the screen, 6 is here, but this other side, there is nothing given there, but the base is the whole of this side. This is the base, this side, where you have 6. So we need to know what this is, right? So that we can add it to 6 to give us the entire base. So what we have to do now is to, we already know the height. The height is 4 cm, but we don't have the base, all right? So what we can do, let's look at this triangle. There are 2 right angle triangles here, this one and this one, all right? So this smaller one, this smaller triangle here, we will look for the other side of it, okay? So let's apply Pythagoras theorem. Applying Pythagoras rule, okay, we will say 5 squared is equal to, that is the Pythagoras rule says the square on the hypotenuse side is equal to the sum of the squares of the other 2 sides. It means, look at the screen, the square of this hypotenuse side, 5 square, is equal to when you add the square of 4 square and the square of this side. This side, we don't know it, we just put it as x. Okay, so it's equal to 4 square plus x what square. So this is 25 is equals to 4 square is 16 is equals to x square, right? So plus x square rather. So x square is equals to 25 minus 16, which will give us 9. Okay, so x square is equal to 9. All right. So let's come this way. So x squared is equal to 9. So to find x, square root both sides, square cancel square, square cancel square root. So x is equal to root of 9 is 3. Should we? So what that now means is that the base, so therefore base is equal to 6 plus 3 is equal to 9. All right? So it said therefore area is equal to 1/2 base times height. So area is equals to 1 over 2. Our base now is what? Times 9 times 4, right? So area is equals to 2 here, 1, 2 here is 2. 2 times 9 is 18 square units, okay? Which is option C, 18 square units, which is option C, all right? Okay, so let's go to the next one, 57. Okay, so let's look at the next question, question 57. So you should find the value of theta in the diagram below. This time they want us to find theta. They have not given us, they didn't give us what theta is, but they gave us two sides of the triangle. So they are asking us to find what theta is. Theta is the angle there. So let's know what it is. Good thing, they have given us two sides of this triangle, all right? Now, I told you the angle, we have to determine the opposite of the triangle is the side that the angle given is facing. So theta is facing 2 whole number 1 over 2 cm. So that is our opposite. So if we have opposite and our hypotenuse is also given 5 cm, so it means we're going to use sine theta, right? Which is so opposite of a hypotenuse, right? So let's do that. Okay, so this is 57. So if I can just quickly sketch that here for you so that you understand what I'm doing. So this is 5 cm. So this is our theta. These are 2 whole number 1 over 2. So this is what we're looking for, right? All right. So you say sine theta is equals to opposite 1 over hypo, right? So sine theta is equals to opposite is 2 whole number 1 over 2 divided by hypotenuse is 5, right? All right, so let's look at what 2 whole number 1 over 2 is. So this will be sine theta is equals to this 4, that is 5 over 2 divided by 5 over 1. So this is equal to 5 over 2 times 1 over 5, right? 5 here, 5 here. So this is equal to 1 over 2. So sine theta is equal to 1 over 2, but that is not what our answer is. They're asking us for theta, right? So let's go. Let me write this thing well here now. All right, so we have, from that explanation, sine theta is equal to 1 over 2. That is, it can also be said to be, once you're giving sine theta, okay, or cos theta, whatever, you are finding theta, it's good you put this thing in decimal point, all right? In decimal number, rather. Sine theta is equal to 0.5. Right? So to get theta, we will get a sine inverse of this, right? So sine inverse of this is just simply you do theta is now equal to sine inverse of this is how to write sine inverse now, right? Of 0.5. So your calculator can help you do that, okay? You just press your second function, okay? And that is done. So let's go. Sine inverse sine inverse of 0.5. Let's look at sine inverse of 0.5. All right, so sine inverse of 0.5 second function sine inverse 0.5. So we're having 30 degrees, okay? So once you punch that in your calculator, it gives us 30 degrees. So that is what the sine inverse is. So if you have your scientific calculator, just press the shift key, okay? That's the second function key where you have the shift. So press it and press sine, okay? Because if you check your sign, you will see in just where the number, where something is written in your calculator there, you will see sine raised to power -1. So that is sine inverse. So to get that function, press shift, okay, and tap on sine. Then put your 0.5. Once you do that, it gives you answer 30 degrees, okay? So this is 30 degrees. So our answer there is B, option B, all right? Okay, so 58. 58 says, in the figure below, find the side marked X, all right? So they say in this figure below, find the side marked X, that is this side, right? I think this is, okay, all right. This is 8 cm, is this 8 cm? This should be 8 cm, what is given there? All right, let's see if that is 8 cm because I can't see that very well. Maybe you check on your own app and see. I think, but this looks like 8. But my point is, there is no centimeter given there, right? Okay, so find the value of this side marked X, right? This side marked S. Okay, so this is what we're going to do to be on a very safe side. Let's find what if this is really 8 cm. We can know if this thing is 8 cm. Let's find this side, if it is 8 cm, by doing here and here, right? So 58. So 10 square, that is the bigger right angle triangle is what I'm talking about, okay? 10 square is equal to 6 square plus that side we don't know whether it is 8. That's what I'm looking for. So let's just call it A, right? So let's see. So 10 square is 100. So 6 square is what? 36 plus A square. This is A square. All right. So A is equal to 100 minus 36, right? And that is 64. So that thing is 8, right? So this is 64. So A is equal to root of 64, which is equal to 8. So actually, this side is 8. Here is 8, okay? This place. So we can find, from what we have here now, we can find the value of X, all right? So we say, therefore, X, applying Pythagoras theorem, X squared is equals to 15 square plus 8 square, all right? So if we look at our 15 times 15, we get 225. So this is 225 plus 64, right? So 225 plus 64 equals to 289. Square root of 289 is 13. So 289, I think, yeah. So square root, so X now will be 289 square root is 13. I think let's confirm that. Square root of 289 17 rather is 17. 289 square root is 17. Okay, so this is 17. So 17 cm. Is that a cm? Sir. So 17 cm. So we have D as the option. All right. So let's look at 59 before the last question. 59 before the last question. It says the perimeter of a lawn, of a rectangular lawn, is 32 cm. If the difference between its length and breadth is 2 cm, find the area of the lawn. Now, this question, look at it very well. Look at it very well. They did not give you what the length is and what the breadth is. It will take us to simultaneous equation. You can go back to our, what is it called? Our playlist, some topics in mathematics where we've treated some of these things. You will see our simultaneous equation class in this channel, okay? All right, so let's see. I think that question will take us to simultaneous equation. So if you have a good knowledge of simultaneous equation, you will know how best to approach this particular question. Is that okay? So let's see that. So we have the perimeter of a lawn tennis is this. You know, the perimeter, this is 50 what? 59. Perimeter is equal to 2L plus breadth, right? 2L plus breadth. So they say the perimeter, so if we say 32 is equal to 2 into L plus B, right? So let's just find a way of getting two equations in this thing. So I want to simplify this thing as easy as possible. Okay? So if we divide both sides of this thing by 2, so this is over 2, this is over 2. So this will give us 16 is equal to 2 here, 1, 2 here, 1. So it's 16 plus L plus B. So L plus B is equal to 16. Let's call this one our equation 1, right? Let's call that our equation 1. The next thing says, if the difference between its length and breadth is 2 cm, difference between its length and breadth is 2 cm, meaning L minus breadth, because the L in a rectangular shape, most times, not most times, the length is usually bigger than the breadth. Okay, so the positive difference must be this. So you say if it is equal to 2, so it means this is equation 2, right? So we have two equations from that. So we can solve simultaneously now, okay? So let's subtract. Subtract equation 2 from 1. Subtract by elimination, right? Subtract equation 2 from 1, right? So what that means is L plus B is equal to 16 minus L minus L minus B is equal to, what is it called? Is equal to 2. Okay? So if we are saying subtract this from this, it means that L minus L will go off, right? So L minus L, this goes off. So we come here now, L minus minus B. Do you get the point? This is B, B, please follow me carefully. For subtracting, we are subtracting this from this. So L minus L is 0, is nothing. Just like 1 minus 1 is 0. 2, you remove 2 from 2 is. So L minus L is. Okay, so now we have B minus minus B. That is B minus minus B. Do you get that now? This will be minus times minus is plus. So this will be B plus B, which is 2B. Can you see that? So this means that, so B minus minus B will give us 2B, because this minus B minus minus B, this minus times minus is plus, so B plus B is 2B, is equal to 16 minus 2 is 14. Is that correct now? So divide both sides by 2, divide both sides by 2. This, B is equal to 2 here, 1, 2 here is 7. So this is 7 cm. That is what B is, rather. So we are not, what the breadth is 7 cm. All right? That is what the breadth is. So we have gotten the breadth. The next thing is to find the length. To find the length, substitute this breadth into any of the equations. So we can substitute into equation 2. So if we put the value of B, which is 7, into equation 2, we'll find it. So what it means is that L minus B is equal to 2. So L minus 7, our B is 7, is equal to 2, right? So L is equal to 7, that is 2 plus 7. So L is equal to 9. So we have now found our length, and we have also find our breadth. So, but remember, the question that was asked is find the area of the lawn tennis court or of the lawn. So area is now length times breadth, right? So this is equals to the length 9 times 7. Okay, so that is, I think, 63. 9 times 7, 63. So 63 cm square. That is option D is the correct option there. Then the last question. The last question. They say in the figure below, line AB and CD are parallel. They say which of the following is not true? Just look at it. If you have checked our classes on angles, okay, this should be an easy question. So now look at now. So which of the following is not true? A is equal to B. Let's look at A. A is equal to B. Yes, that is true because alternate angles are equal. So A can be equal to B, right? That is right. Then B, they say A is equal to C. A is equal to C. You're looking at the screen, right? A equal to C. Yes, that is true. Vertically opposite angles are equal. So A is equal to C. They are vertically opposite. See them now. Just look at the way my mouse, my cursor is just going opposite the two angles, okay? Then we have B is equal to C. B is equal to C. That is correct because corresponding angle, B is corresponding to C. How do I mean? The position or the pattern of the angle of B is the same pattern of the angle of C. Okay? Is immediately after you see the line, the horizontal line, just on top of the horizontal line. That is where B is. On top of the horizontal line, that is where C is. So we call those angles corresponding angles. So B is equal to C, right? So we have B is equal to D. B is equal to D. B is equal to D cannot be true because there is no angle theory that makes that true. All right? There is no theory that says that this angle is equal to this angle. Do you understand the point now? So C is not true. Let's see. D plus A is equal to 180. Where is it? D plus A is equal to is equal to 180. Yes, sum of angles on a straight line. So it's also true. So the one that is not true is option D. It is not true. So that is all right. So we are done with this particular exercise. We've been able to solve the past question of BECE 2023 paper 1 from from number 1 to number 60. I believe so much that if you go listen to this video watch this video very well, practice some of these things, go back to your notes and study these things, you will come out in flying colors. Thank you very much for your time.